establish the connection to our bucket, so where we want to load the data from. This means we create the stage, and then we also want to load the raw JSON file. And then we will afterwards parse this data, flatten it, and then load it into our final table. But first of all, we just want to get the raw data. So how we do this? Step number one, we create a stage object. So we do this in this first command, and we just call it JSON stage. And we, of course, specify the location, so the URL. And in this case, it is a publicly available bucket. So this is how we can set this up. I'm going to execute it. And step number two, we also create a file format object, which we just put in the location of the file format schema, and we call it JSON format. We only specify the type, which is JSON, and for all of the other properties, we just use the default values in this file format object. So let's go ahead and also create this file format object. And now we want to establish the table. So we want to create our raw table. So this is JSON raw, and we use for this the special data type variant, which we are going to talk about a bit more, of course, in this section. So this is a very flexible type that can work with JSON data and other semi-structured data very well. So we will just load each of those objects, or each of those records that we can see in our file. So in here we can see we have multiple of them, and each of them will be one row. So this is how we want to do this. And of course, we will see how this works practically. But first of all, let's set up this table. And now we want to copy this raw data. So here we just use this stage that we have just created. We want to copy it into this table that we also just created. And for this, we use the file format object, and here we specify it directly. And also, we want to specify the file that we are going to load. So this is this HR data, which is a JSON file. Okay, so let's go ahead and just copy this file into our table. We see all of the rows have been loaded successfully. This is nice. And now we want to, of course, have a look at the file. So if I execute it, I can see that now this has been loaded successfully. And this looks exactly like we want to have it. And we can also select those records. And if I do this, I can see how this looks like. So in this case, I can see that I have this information. So here we have the information about this column. And if I want to see how this looks like, I can just see that this has been actually interpreted nicely as JSON file. So you can see if I want to expand it, I can have a closer look at it, and I can also copy this value. So you can directly see that this has been actually already correctly interpreted as JSON, because we can see how this looks like, that this is, also already showing us that this is understood what this means in some way. And of course, now we need to still deal with this in a better way, because like this, we cannot work with this so easily. We want to maybe analyze it more, and therefore we need to see how we can now work with this, how we can parse the data, and how we can flatten it. And how this is done, we will see now in the next. Number two, which is to parse the data. This means now that we have loaded this data, we cannot work with it so easily. So we need to basically convert it into a format where we are able to work with this in SQL, in these tables, in a structured way. So this is what we want to focus on in this lecture, because now we don't have really these columns. We still have it in this very raw format with these attributes like city and first name and so on. So what we want to do is we want to, for example, query all of the cities. And then we want to be able to analyze this. Maybe we want to count the cities and so on. So how we can do this is we can use some options in Snowflake to be able to select those attributes, and also then we can convert it into different data types. So how we do this is we just use this colon basically, and then the attribute name. So of course, first of all, we select our column. In our case, this is the only column called raw file. And here we use then the attribute city. And of course here just we select our JSON raw table. So this is just our table that we have. And if we do this, we actually now get all of those values from this city attribute. So this is now very nice because now we can deal with this. Of course, still this column name doesn't look really nice. And also maybe those quotes are also not what we want to have, but we will deal with this in a bit as well. But first of all, we also want to have a second way, and this is not using the name of the attribute, but the number, so the index. And if we have, in this case, only one column, then we have, of course, this one. So in this case, we can also, instead of using the explicit column name, raw file, we only have this one. We can also just use the number. So for this, we would have to use $1, and then we would see the first column. So this would be exactly the same, and we want to demonstrate this here with the name. So yeah, this can also be done like this. So here we see all of those names. And now we, of course, want to also format this a bit nicer. As we have seen, these are maybe not what we want to have, those colons. Maybe we want to have this as a number or as another data type. And to do this, we can convert it using this double colon. So for example, as with the name here, we just use the double colon and then the format that this should be converted into. And of course, we can also give it an alias. We do this after the name of the column, or after we have selected this, we just specify the new name as an alias in this select. So for example, in this case, if we execute it like this, it now looks much nicer. So now it is actually converted into an actual string, and we know this is how it's interpreted, and we don't need to show those double quotes anymore. We can also do the same thing, of course, with the integer values. If I would just execute it like this, I can see that if I now select this column, that this is still of the data type variant, which is also relatively flexible. So we can see that we can also work with those numbers like this, but we can also explicitly convert it into an integer, which is of course what we should do if we want to put it into another table. So in this case, it is an integer. And if I execute it like this, I can now see, if I select those values, that now they are actual numbers. So now they are converted into those numbers, and we can now easily put this into a table. So if we now combine everything, so we have the ID, for example, as an integer, first name, last name, and in this case also the gender as a string, and we just give them nice aliases, we almost have already a very nice table. So now it is very structured, but of course we remember that we had some more challenges with those nested data, for example. So if we remember the job, if we have a look at the data there as well, we can see that if we have a look at the job, it was nested. So here we have the salary as well as the title. And of course, if we select it in our case, this makes it again a bit more difficult, because here we can see we have this still a bit, not so easily to work with it, because if we, for example, want to just get the salary, how should we do this? So we need to have a way to deal with this nested data. And how this works, how we can do this, we now want to have a closer look at how we can handle nested data. So we have some hierarchical data, and in a JSON file, we want to see how we can also put this into a structured format that we need, of course, in our analytical database. So for example, we remember we have here this job, which we have also queried in here. We can see that if we just run this command where we just basically query the column or the attribute job, and we want to see how this would look like, we can see this is how it looks like. And in here we can also see that. So here, this is basically the parent attribute. And here we have those two child attributes. And in Snowflake, we can also deal with this in a relatively simple way. And the way to do this is to use a dot. So you can see if I use this dot after this attribute, I can access a child attribute in a hierarchy. This is how it works. So you can see again, job is our main attribute. We use the colon to access all of our main attributes, as we can see in here. For example, the job. And then if an attribute is nested into a hierarchy, we can access the children or the child attributes just by using this dot. So you can see dot salary will give us the salary itself, and we can also again cast it with those two colons. So let's have a look at this. We can see this is actually what we expected. It indeed works. And now we can of course combine this with other columns. So for example, the attribute first name, and also of course not only the salary as a child attribute, but also the title as a child attribute. So if I execute it like this, I can now see that now this looks much more like a well-structured table where we now have the salary and the title into separate columns. So this is how we can access the items or the attributes in a hierarchy by using a dot after the first attribute to access those child attributes. But now, of course, we have additional challenges, and these are here with those multiple values in an array. So therefore, in the next lecture, we want to have a look at how we can also work with those arrays. This is what we do in the next lecture. Look at a more practical way of how we can work with a little bit more complex and this hierarchical data in a practical way. So how can we do this? First of all, let's have a look at the problem. So if we query the spoken languages, and you remember we can access those columns or attributes in this JSON format by just using the colon and then the attribute. So spoken languages will basically give us the spoken languages, which is an array, we remember. So there can be multiple languages spoken, and then each of those language objects is also in a hierarchical or nested structure. So we have here the language and then the level of this language at this is spoken. So here we have, of course, a few options. So of course we could aggregate it. If we only want to know the number of rows or the number of languages that are spoken, we can just use an aggregate function like array size, and then this would give us just the number of objects in this array. So for example, here we have the first object, language 1, and here the second one. So in this case, we would just aggregate it like this. And of course, now if we combine this with the name, we would get the number of languages that are spoken by each of the people. But of course, again, we lose here lots of information, and we want to break this down. And the goal of this, of course, is to make it in a format that is structured so that it is optimized for our analytical purposes. So we work in a relational database, so therefore we want to have this table structure that we can easily work with, easily aggregate it, easily join the data, and this is our goal. So what are the techniques that we could use? Well, first of all, we know that with these nested objects, so in an array, we can just use the index. So we can just use these brackets and access the individual elements. For example, with the language, if we just access the first language, and in this case, of course, we can also combine it with the person, we would then see that this is just the first language for every person. So here you could see that we have two problems. First of all, this is only the first language. And secondly, this is still in this nested structure. So here we cannot really analyze it. We cannot aggregate it. And this is not the way that it should be. So we want to have it in a more clean structure, optimized for our analytical purposes. So we want to have the language in a separate column, the level in a separate column. And then ideally, we want to see, of course, all of the languages. So how can we solve this? Well, of course, we know that we can also access the elements by using a dot. Like this, we can access the elements within this hierarchical structure. So I could add after spoken language and then this element, also just a dot, and then say I want to access this language. And then I put it into a separate column. And in the other column, I have another one. So for example, here, I want to access the level. And this would then give us this in a cleaner structure. So now we have those elements broken down from this hierarchical structure, which we have already seen before. So like this, we can now work with this, but we still have the problem that this is only the first language. So how we could now access the other elements? Well, we have again a few options. So we can just use the one, for example, for the second element. And then something that we could do is we could just union this again, as we have seen also before. So here we have the second element, and then we union this, so we get additional rows. And then maybe also we have a third element, so we just also union this. But we will see that this is actually not a good approach. So this is a very fixed approach, and it works in some way. So here we see, for example, those two languages broken down exactly how we want it, but then we have here these redundant rows. So here there's, of course, no more language for this person, and therefore it will be just nulls, because this third object just doesn't exist for this person. And then here we can see this is also the case, for example, for some other people. And this is really not a good solution. Of course, we could filter it out again, but again, this is just more complicated. And also, what if we have 4 languages? Then it is again another problem, because then we would not see this fourth language with this very fixed approach. So therefore, we have another function available to flatten this data exactly to our needs in a very dynamic way. So for this, we would use the flatten function. This is there to flatten the data in a nested object. For example, when we work with JSON data, this is what we oftentimes use to just easily work with this data. So we use this table function construction with this flatten function, and like this we can basically use this table or this output as if it would be a table, and we can query from it. And like this, technically speaking, we will just join this with our initial table, and then we access the elements from this construction here. So here the level and the language, we can just access those values, and then we basically flatten this out in a dynamic way, exactly like this is here. So let's first of all have a look at this result, and then we can break it down further. So you can see now we have no more nulls, and we can see all of the values in a dynamic way, because we use this construction with this flatten function and this table function, so that we just have to use, here by the way, we can also just use an alias, and then we use the value keyword, and then we can just access the individual elements like the language just by using this colon. So we have just the value, and then afterwards the language and the level. So just those objects within this hierarchy. So this is how we can use the flatten function in a way that is flattening our data when we work with JSON objects. And like this, we can work with our data and prepare it in a much better way for our analytical purposes. So this is how we can use the flatten function. Hope it was helpful.